I want you to close your eyes for a second. Well, don't close them if you're driving, but just imagine this.
Okay, I'm with you.
You are standing on the deck of a ship out in the middle of the Atlantic Ocean. It is gray, the swells are rolling, and right in front of you is this massive flat steel expanse.
Like a tiny aircraft carrier.
Exactly like an aircraft carrier that shrank in the wash. It's a 122-meter modified barge.
Which is quite the sight. It's basically this floating concrete slab out in the middle of nowhere.
Right. And painted across the side of this vessel in giant block letters is a name that feels, well, a little too perfect for what we're talking about today. The ship is named Return on Investment.
It is a bit on the nose. But you know, in this industry, names really do matter.
They do.
And that barge isn't just some billionaire's inside joke. It is literally the future landing pad for a massive new rocket, a rocket that is absolutely central to the story we are unpacking today.
Yes, because today we are doing a deep dive into Rocket Lab. Ticker symbol RKLB. Now, usually when people talk about the whole new space race, there is one giant gorilla in the room.
SpaceX.
Right. They suck up all the oxygen, but quietly, methodically, Rocket Lab has positioned itself as the only other private entity that is reliably putting satellites into orbit.
And look, the timing of this conversation could not be more critical. Today is Thursday, February 26, 2026.
A very big day.
Huge. Later today, after the bell, Rocket Lab releases their pivotal fourth quarter earnings. And the market is holding its breath. I mean, this company has evolved from a quirky startup in New Zealand into a $37 billion U.S. defense contractor.
Which is a staggering transformation when you think about it. So our mission for this deep dive is to move past those flashy headlines.
Yeah, we need to dig into the actual mechanics of the business.
Exactly. Specifically why they are pivoting away from just launching rockets to actually building the things that go to space. We need to look at the financials, especially that record-breaking Q3 and the pressure on today's Q4 release. And we need to talk about their broader sector strategy and finally the wild vision of their founder, Peter Beck.
It's a classic case of what the market thinks a company does versus how the company actually makes its money.
So let's start with the operations. The actual machine that built the brand, the Electron rocket.
The workhorse.
Right. And for listeners who haven't seen one, the Electron is visually very distinct. If you look at a lineup of rockets like the Falcon 9, Atlas V, Ariane, they are all white or silver. The Electron looks like it's wearing a tuxedo. It is jet black.
That is a great description. And the reason it's black isn't just to look cool, though it really does look cool.
It really does.
It's because the entire rocket, from tip to tail, is made of carbon fiber composite.
Which is unusual, right?
Oh, extremely. Most rockets use aluminum or stainless steel alloys. But Rocket Lab went with carbon fiber to save mass. A lighter rocket means you can carry more payload.
Makes sense.
But working with carbon fiber for cryogenic fuels, like liquid oxygen that is hundreds of degrees below zero, that is incredibly difficult.
Yeah.
Because carbon fiber tends to get brittle and crack at those extreme temperatures.
So they basically had to invent entirely new material science just to make the tank hold together.
They did. But the real innovation isn't the skin of the rocket. It's the heart, the engines, the Rutherford engines.
These are the 3D printed ones. I remember reading that in the sources and thinking, wait, you can just print an engine?
You can. They print the primary components in about 24 hours.
Oh, wow.
But the 3D printed part is just the manufacturing method. The real aha moment is how they actually work. See, most rocket engines use all this complex plumbing, gas generators, turbo pumps, all to shove fuel into the combustion chamber.
Lots of moving parts.
Exactly. It's heavy, it's complicated, and if one single seal breaks, the rocket explodes.
And Rocket Lab ditched all that plumbing.
They replaced it with batteries.
Batteries on a rocket.
Yeah, it's an electric pump-fed engine. They strap high-performance lithium polymer batteries right to the side of the engine to spin the pumps.
That sounds almost too simple.
It is simpler. It's easier to control, and it's much cheaper to build. It was a radical idea when they first proposed it. People in the industry said it flat out wouldn't work.
But clearly it does because they've done over 81 missions now.
Correct. And that reliability allows them to launch very frequently. They actually have a private pad in New Zealand on the Mahia Peninsula.
Which is a huge advantage.
Massive, because they don't have to fight for slot times at Cape Canaveral. And they also have a facility at Wallops Island in Virginia for when the U.S. government needs a secure launch on American soil.
Now, while we are talking about the Electron, we really have to mention this variant called HASTE. Because going through the research, this seems like a weird detour. It stands for Hypersonic Accelerator Suborbital Test Electron.
It is a mouthful. I know. But haste is a brilliant business move.
Explain that. Why do a suborbital rocket?
Well, putting things into orbit is fundamentally hard. You have to go very fast and get very high. But sometimes the Department of Defense just wants to test something that goes fast, like hypersonic speeds, Mach 5 and above. But they don't actually need it to stay in space.
Right.
They just need to test a new heat shield or a scramjet engine in the upper atmosphere.
So Rocket Lab just takes an electron, tweets the trajectory, and says, hey, we'll just throw your experiment really fast through the atmosphere.
Exactly. They're reusing their existing, proven assembly line to serve a totally different market: hypersonic missile testing and defense research. It's strictly suborbital, but it pays very well.
It's incredibly smart. But this brings us to what I think is the biggest misconception about Rocket Lab. If you ask the average person what they do, they'll say, oh, they're a trucking company. They truck satellites to space.
And that is the trap. If you value Rocket Lab solely as a launch company, their current stock price makes 0 sense.
Because launching rockets is flashy.
Right, it gets the YouTube views. But strictly speaking, launch is a low-margin, high-risk game.
So where's the actual money coming from? Because I looked at the revenue split in our notes, and it honestly blew my mind.
It's coming from a segment they call space systems.
Which essentially means building the satellites themselves.
Building the satellites and everything that goes on the satellite. Think of it this way. During the gold rush, the real money wasn't in digging for gold. It was in selling the shovels.
Right, the Levi's jeans and the pickaxes.
Exactly. Rocket Lab started out by just selling the ride to the mine. But now they're selling the shovels, the pickaxes, the jeans, and the tents.
I love that analogy. So imagine if FedEx didn't just drive the delivery truck, but they actually manufactured the TVs and the computers that were inside the shipping containers.
Precisely. They realized that their customers, these various startups and government agencies, they didn't just need a ride to orbit. They were struggling to even build the satellites in the first place.
So Rocket Lab said, just let us build it for you.
Yeah, they have a satellite bus called Photon.
And bus is just industry jargon for the chassis, right?
Right. The bus provides the basic power, propulsion, and navigation. So the customer just screws their specific sensor or camera onto the bus, and Rocket Lab handles all the rest. They provide the solar panels, the star trackers, the reaction wheels.
Those are the heavy flywheels that spin to orient the satellite in space.
Yes, exactly. And they provide all the software to run it.
And this leads us directly into the financials, because this pivot to space systems isn't just a fun theory. It is completely dominating their balance sheet right now.
It really is.
Yeah.
Over the last few quarters, launch is only about 25 to 30% of their revenue. The vast majority, 70%, is space systems.
Wow.
And the margins on that hardware are so much better than launch. Launching rockets is messy. You have weather delays, range issues, fuel costs. But building hardware in a clean room, that's predictable.
Let's actually look at those numbers, because we have the data from Q3 2025, the quarter right before the one dropping later today. Those numbers were record-breaking.
They were. Revenue hit $155 million, which was nearly 50% growth year over year.
But the number that really made Wall Street sit up and pay attention was the gross margin. It hit 37%.
Yeah. For complex aerospace hardware, 37% is incredibly high. It shows they have real pricing power and they have their manufacturing costs dialed in. Plus, thanks to a recent capital raise, they're sitting on over $1 billion in cash liquidity.
So let's recap that. High growth, great margins, $1 billion in the bank. You would think the stock would be at all-time highs. But as we sit here today waiting for the Q4 numbers, the stock is actually down about 30% from its peak earlier this year. Why the sudden pessimism?
It all comes down to the elephant in the room, or rather the new rocket in the room, the Neutron.
Neutron. This is the big brother to the Electron.
Much bigger. So Electron lifts about 300 kilograms to orbit. Neutron is designed to lift 13,000 kilograms. It is a medium lift, fully reusable rocket designed to go head-to-head directly with SpaceX's Falcon 9.
And this is where that barge, return on investment, comes back into the story. That's what Neutron is supposed to land on.
Correct. But developing a rocket of that size is exponentially harder than building a small one. And last month, in January, they hit a major wall.
The tank rupture.
Yeah, the stage 1 tank rupture. They were doing qualification testing. That's where you overpressurize the fuel tanks on the ground to see if they can handle the intense structural loads of an actual launch.
And it popped.
It failed structurally. Now, to be fair to Rocket Lab, this is a normal part of the development process. You test to failure on the ground so you don't fail in the air.
Right.
But it happened at a pressure level lower than they wanted, and it happened much later in the development timeline than they hoped.
And if there's one thing the market absolutely hates, it's delays.
They despise uncertainty. The maiden flight for Neutron was originally supposed to be early 2026. Now the official guidance is mid-2026 or later.
Ooh.
And when you hear or later in the aerospace industry, investors immediately get flashbacks to other space companies that promised timelines and never delivered.
Like Virgin Orbit or Astra.
Exactly. The fear is that mid-2026 becomes late 2026, which then bleeds into 2027. And every single day Neutron isn't flying is a day they aren't earning revenue on those massive launch contracts.
So on today's earnings call, yes, the revenue guidance matters, the $170 to $180 million they're projecting, but really everyone is just listening for an update on that tank.
That is the only thing that really matters for the long-term thesis right now. Did they fix the structural flaw? Is the new timeline realistic?
But let's assume they do fix it, because unlike those other failed companies you mentioned, Rocket Lab actually have that billion-dollar war chest. They can afford to make a mistake and fix it.
That is the key differentiator here. They actually have the financial runway to solve hard engineering problems.
I want to pivot to the sector and strategy now. We established they are selling the shovels for the gold rush. But they didn't just build all these new capabilities from scratch in-house, right? They went on a bit of a shopping spree.
Yes. This is their vertical integration strategy at work. In the aerospace supply chain, you are constantly waiting on outside suppliers. If your solar panel guy is delayed by 6 months, your entire satellite is delayed by 6 months. So Rocket Lab just went out and bought the solar panel guy.
That was solar, all right.
Yes. And they also bought a company called Geist for about $325 million.
What does Geist do?
They make the eyes, high-end optical sensors for national security satellites. So if the U.S. government wants to track a missile launch or monitor a specific border, they need Geist sensors. And now Rocket Lab owns that entire capability.
And there was one more big one,
Mynaric. They deal with laser communications.
Lasers in space.
It sounds totally sci-fi, but it is the actual future of data transmission.
Yeah.
Right now, most satellites use standard radio waves to talk to Earth. It's slow, and the radio spectrum is incredibly crowded.
Right.
Lasers allow you to transmit massive amounts of data directly between satellites almost instantly. It's basically like moving from dial-up internet to fiber optics, but in orbit.
So by buying Mynaric, they are betting that the future internet backbone in space will be entirely optical.
Exactly, and they bought it at a pretty steep discount because Mynaric was struggling with some internal restructuring. It is a risky bet, but if it pays off, Rocket Lab suddenly controls the communication layer too.
This all points to them becoming what the industry calls a prime contractor. Can we break down what that actually means in practice? Because I hear that term a lot in defense reporting.
Sure. So in the old days, a massive company like Lockheed Martin or Boeing would be the prime. The government gives them the billion-dollar check. Then Lockheed would hire a bunch of smaller subcontractors to build all the individual parts.
And Rocket Lab used to just be a subcontractor, just the guy driving the delivery truck.
Right, but now they are going directly to the Space Force and saying, don't hire Lockheed, hire us. We will build the satellite. We will put our own custom sensors on it. We will launch it on our own rocket, and we will operate it for you in orbit.
They just want the whole pie.
They want the control, and they want the margin. And they are actually winning those contracts. They have a current backlog of over $1.1 billion. A huge chunk of that is a $515 million contract with the Space Development Agency, the SDA.
This is for the Missile Defense Shield.
Part of it, yes. It's called Proliferated Low Earth Orbit. The military recently realized that having one giant multi-billion-dollar spy satellite is actually a really bad idea because it's a giant, juicy target.
Right, if an enemy shoots it down, you're suddenly blind.
Exactly. So the new strategy is strength in numbers. Launch hundreds of smaller, cheaper satellites. If the enemy shoots down 5 of them, who cares? You have 300 more up there doing the exact same job.
And Rocket Lab is perfect for this because they literally specialize in mass producing these smaller, high-performance satellites.
Is a perfect match for their capabilities.
It's a fascinating pivot. They've essentially become a defense contractor that just happens to make rockets on the side. But I want to talk about the culture of the company, the overarching vision, because it feels very different from a Raytheon or a Boeing. It feels much scrappier.
That entirely comes from the top. Peter Beck, the founder and CEO.
He's an interesting character. I read in the sources he didn't even go to university.
No degree at all. He started out as a dishwasher, then worked in appliance design. He was literally building rocket engines in his garden shed in New Zealand. He has this intense philosophy of hiring doers.
I saw a quote in the research where he said he'd rather hire the kid who built a go-kart out of a lawnmower engine than the kid with a 4.0 GPA who never actually got their hands dirty.
And that culture really pervades the entire company. They move fast, they break things.
Like the neutron tank.
Exactly like the tank. But they analyze it, they fix it, and they move on. It is very reminiscent of the early SpaceX culture.
Beck also has this broader vision that goes way beyond just defense contracts. He talks a lot about improving life on Earth.
Which sounds like a generic marketing slogan, doesn't it?
Yeah.
Space for Earth. But his actual argument is incredibly compelling. He usually uses GPS as the prime example.
We totally take GPS for granted. I mean, I panic if Google Maps doesn't load my route in 5 seconds.
We all do. But think about the cascading failure across society if GPS actually went down. It's not just that you'd get lost driving. Financial markets rely on the precise timing signal, from GPS satellites to timestamp every single high-frequency trade.
Wow, I didn't know that.
Yeah, and the power grid uses it to synchronize the flow of electricity across the country.
So if the satellites stop talking, the ATMs stop working, and the lights literally go out.
Exactly.
Yeah.
Beck calls space the invisible infrastructure. His argument is that we critically need redundancy. We need a second reliable provider to ensure that infrastructure never ever fails.
But he's not just staying in Earth orbit to protect that infrastructure, is he? There's this Venus mission.
The Venus Life Finder. This is pure Peter Beck.
It sounds like the plot of a sci-fi novel, a private company just deciding to send a probe to Venus.
And not just to look at the rocks. They are actively hunting for aliens, or specifically microbial life.
In the clouds, right.
Yes, because the surface of Venus is absolute hell. It melts lead. But about 50 kilometers up in the atmosphere, the temperature and pressure are actually remarkably Earth-like. Scientists found traces of a gas called phosphine there a few years ago, which could potentially be a signature of biological life.
And NASA isn't immediately following up on it.
NASA moves at the speed of government. Beck just looked at it and said, well, I have a rocket. I have a satellite bus. I'm just going to go check myself. They are targeting a launch this summer in 2026.
That is incredibly bold. It's high risk, and it generates zero revenue.
True, but it proves a massive point to the industry. It proves Rocket Lab can do complex interplanetary logistics. If they can get a payload to Venus, they can get to Mars. And in fact, they already have a study contract with NASA for the Mars sample return mission concept.
So they are quietly positioning themselves as the FedEx for the entire solar system.
Exactly. If you need a package delivered to the Moon, Mars, or Venus, Rocket Lab wants to be the courier you call.
So pulling this all together, we have a company that has completely mastered the small rocket market with the Electron. They are generating massive revenue by building complex satellites for the military. They're sitting on a huge pile of cash, but they are currently facing a real production hell moment with their big new rocket, the Neutron.
That is the perfect summary. They've officially graduated from startup status. They are a real player now, but they are entering the absolute most dangerous phase of their existence. Scaling up to a medium-lift rocket is brutally hard. The physics are completely unforgiving.
Hit if they pull it off.
If they get Neutron flying regularly and they keep winning these massive defense contracts, they essentially become the de facto Pepsi to SpaceX's Coke. And in a trillion-dollar future space economy, being a reliable number 2 is worth a massive amount of money.
It's a high-stakes bet, and today's earnings call is going to give us the very next clue on whether that bet is actually paying off.
Watch the guidance on the Neutron timeline today. That is the signal. Everything else is just noise.
Here's a final thought for you to chew on as we close out this deep dive. We spend so much time worrying about our physical infrastructure down here. We worry about bridges collapsing or roads crumbling. We worry about cyber attacks on the terrestrial power grid. But we rarely ever look up.
The space backbone.
Exactly. If we are moving toward a world where the internet, global finance, weather prediction, and national security are all permanently hosted in orbit, then the companies that build and maintain that network aren't just aerospace companies anymore. They are the ultimate insurers of the modern way of life. Rocket Lab is betting $37 billion that the world is going to demand a second insurance policy.
And redundancy always seems too expensive right up until the exact moment you need it. Then it's priceless.
The market closes in just a few hours. Keep a close eye on the ticker RKLB. It's going to be a very interesting afternoon. Thanks for joining us for this deep dive.
See you on the next one.